Okay, so this is Monday, getting ready for homework 4.3. We're going from 4.1 to 4.3. What questions would you like to ask on assignment 4.1? Now's your chance. Yes, Shriana.
Problem 41, so we were supposed to do it, and then it was not, at least when I checked, on the answer key.
Right, okay, so the question is, where's problem 41? Tell me, what was the original problem for number 41?
I can't remember exactly. It was like you had to
Oh,
make
it's,
up.
Oh, so someone who does have it. Sam, do you know?
Yeah, so first is f double prime of x.
Oh, no, that one was not supposed to be assigned. If that, yeah, the f double prime of x was not supposed. So if you didn't get that, don't worry, that was not intended to be assigned. Further questions on the homework?
34.
34? All right, let's take a look at number 34. 34 star. This one right down here, antiderivative 3 dt. Okay, so you can think of 3 as 3t to the 0. So when you add 1 to the exponent, divide by the new exponent, you get 3t plus a constant of integration.
But what is like, how do you get 3 to 3t?
Well, I mean, keep in mind, there's a couple of ways to think of that. You can think of 3 as being a scalar multiple that comes out front. So it could just be 3 times the antiderivative of nothing dt, which then looks like an empty canoe, if you will. But we know that when there is an empty canoe in there, it's really the number 1, right? So this is 3 times, and then the antiderivative of 1 would be t plus a constant. So 3t, and 3 times a constant is a constant. So either way, you get 3t plus t. Now, when you ask me the question, where does the t to the 0 come from? Keep in mind that that is, that t to the 0 is 1. So it is fair to make that substitution, right? T to the 0 is 1. So I can just rewrite that as 3t to the 0. If you want to be able to use that formula of add 1 to the exponent and then divide by the new exponent. Does that answer your question then? What other questions, if any, would you like to ask about the homework? Now's your chance. In some ways, I'm surprised that no one's asked yet about number 42 star. Is there anyone that would like an explanation of what's going on with the negative signs on that one? Or are you, yeah, okay, thank you for asking that. Now, first of all, and let me zoom in on this just a tad so that it can be seen on the camera. Notice that the calculus doesn't come until later. The first part of the problem is pre-calculus. And since sine squared x plus cosine squared x equals 1, I can replace 1 minus cosine squared x with sine squared x. It's a pre-calculus move. The next pre-calculus move is to rewrite sine squared x as sine x times sine x. And so here we have cosine over sine is cotangent, 1 over sine is cosecant. This is a moment at which we have to doctor up the problem, because we know that the derivative of cosecant is negative cosecant cotangent, but we don't have the negative sign. So what you can do is doctor up the problem with the negative sign, but you can't really go around changing the problem unless you counterbalance that. So this is actually a foreshadowing of something we're going to be doing a lot today called doctor and counterbalance. If you're just a constant away from the formula that you want, you can just put it in. That's called doctoring up the problem. As long as you counterbalance it with something that would result in ultimately multiplying by the number 1. You're allowed to multiply things by 1. That won't change it. So this is called doctor and counterbalance. So Elijah, does that answer your question now? Yeah, so this green negative sign is copied down there. You could think of this if you wanted to. So I'm zoomed in, I'm not sure this is actually going to work. Sometimes when I'm zoomed in, I can't use all the features of the software. But this negative sign right here, I'm going to put it in a different color. I'll make it purple. So this part of the problem just became cosecant x plus a constant. That negative sign tagged along from up above. Any other questions you'd like to ask about the homework that was due today? Yes, Kristen.
Number 27.
Okay, 27.
Like this one factors, but well, like cancels. But what happens if you have x in the numerator?
Oh, okay. So, wait, now you're saying that this one
Yeah, this one,
is one where we can distribute the square root to all three terms.
yeah, but what if it don't?
So you're talking about a different problem. Can you give me an example of the kind of problem you're talking about?
Like x squared over x plus 2.
Oh, yeah, we'll learn how to do those today.
Oh.
Yeah. And short answer on this, though, is that, although, actually, yeah, here, since the degree of the numerator is bigger than the degree of the denominator, you'd want to do a polynomial long division to rewrite it. So, yeah, those are actually several lessons down. Well, they'll be in this unit, but that's not, fortunately, that's not what you needed for this lesson. All right, so let's go on to the new material. And got paper notes for you. If you were absent, then, and if you want the paper notes from the day you were absent, then first of all, if you're absent, here's the paper notes and the problem set from when you were absent. Come and pick both of those up here. If you are not absent and you just want today's paper notes, they're right up here. So come to the table by the door to get today's notes.
You don't need your own ones, right? We're not making it out of
All right, let's begin. Problem 1. Now, the goal for today is to learn how to do integrals, basically find antiderivatives. It's a technique called substitution. So, again, if you can't see the board, feel free to move to a spot where you can clearly see what's going on. Sometimes this topic is called U substitution. So substitution or U substitution might be a more memorable name for today's lesson. And why do we need U substitution? Well, if you take a look at problem 1, and as I'm looking at it, I'm probably like you, it's like, are there any functions where the derivative is equal to this? Does anything come to mind? Like, is sine x a function whose derivative is this? Cosine x, natural log x? Let's see, natural log x, the derivative of that is 1 over x. Am I correct that nothing comes to mind? So, watch what a U substitution can do. I'm going to let U equal not just x cubed, but everything that's under the square root symbol. And in this first example, I'd just like to show you how this makes things much more manageable. Now, one of the ideas that you're not going to be writing down, but I do want it to go through your mind, so I'm going to put it in temporarily over here in a little cloud that represents your imagination. In your imagination, we're going to substitute U in for the binomial 1 plus x cubed. Now, in your imagination, you know that du dx would be equal to what? Raise your hand if you think you know what the derivative of this with respect to x is. Just raise your hand. Yeah, Jack, go ahead.
3x squared.
It's 3x squared. Okay, so that's in your mind, but you're not going to write that down. When you see, and here's more stuff that you're not going to write down. It looks like the cloud is growing. So this is an extension of your imagination, which you may or may not want to write down. I mean, I'm just hoping that you'll just take in the show. But you could think of du dx as being a lima bean-shaped operator, ddx, with an input of u. Like there's the bean, and then here's the little p inside of the lima bean. The bean inside the lima bean. Or you could think of du dx as being a ratio of soccer balls. It's like purple soccer ball over green soccer ball. You can think of it as soccer ball divided by soccer ball. Now, if you think of it as du over dx, then we could multiply both sides by dx. We could bring this dx over to the other side and say, well, du is 3x squared dx. Why? Because we multiply both sides of this blue equation by dx. Do you buy it that du is 3x squared dx? That's what we're going to write down. We're not going to write down any of this stuff. What we're actually going to write down is that if u is 1 plus x cubed, du is 3x squared dx. We don't say times dx, we just say 3x squared dx. So I'm going to try to quickly get rid of the stuff that is to be thought about but not written down. And that's going to be a translation guide. Now, just want to show you what's going on here. This elongated S is a semi-permeable membrane through which numbers can pass, but variables shall not pass. So, let's make this move here. Would you cross off the 10 and bring it up front? 10 just passes right through. 10 is not affected by the antiderivative process. And now what we are going to do is try to match 3x squared dx with our problem. We can almost make the substitution. Yeah, clearly this is a nice fit. 1 plus x cubed can be replaced with u. It's a nice fit. There's not a nice fit here. X squared dx doesn't quite fit with 3x squared dx. This is where we doctor and counterbalance. When I say go, I want you to say out loud and in unison. It's time to doctor and counterbalance. Ready? Go.
It's time to doctor and counterbalance.
Using doctor as a verb. So we need to doctor this up. du is calling for 3x squared. We don't have 3x. Let's doctor it up with a 3. That's doctoring. Go ahead and doctor up the problem so that it has a 3 in there. Sorry, you can't go around doctoring up problems unless you counterbalance them with a divided by 3. If you're going to multiply by 3, you counterbalance by dividing by 3. So now what we're looking at is a problem which looked hopelessly complicated can now be rewritten as 10/3 times the antiderivative of du over the square root of u. I mean, can't all of this stuff be replaced with du? 3x squared dx, we said that's just du. And the square root of 1 plus x cubed, that's just the square root of u. So it's a radically less complicated look, which, by the way, can look even cleaner if we go 10/3 antiderivative 1 over the square root of u du. It's important to know that this is the same thing as that. Now, we're not done yet, but we've got through the hardest part of the problem. We've transformed this difficult-looking problem from something that looks scary to something that looks like it's right off of last night's homework. Something that's really doable. In fact, my next move is going to be to write this as 10/3 times the antiderivative of u to the negative 1/2 du. Because the square root of u is the same thing as u to the 1/2. And if I bump that up to the numerator, it becomes u to the negative 1/2. Now we can actually take the antiderivative. The antiderivative of u to the negative 1/2 is u to the positive 1/2 divided by 1/2 plus a constant of integration, which even if you multiply that constant of integration by 10/3, it'll still be a constant. So it looks like the final answer is going to be division by 1/2 is the same thing as multiply by 2, so it's 20/3. U to the 1/2 is the square root of u plus c. But we can't leave it like that, because if you begin the problem in x, you have to finish the problem in x. So let me just turn the camera over here a little bit. So the final answer is going to be 20/3 times the square root of u, which is really 1 plus x cubed, plus c. Okay. Now, that's our first example. I'd like to pause here and take any questions you might have. Eli, go ahead.
So the 10/3 doesn't distribute to the C?
Well, sure it does. I mean, if you want to, you can say it's 10/3 times 2 squared of u plus 10/3 times c. But 10/3 times c is a constant. It gets absorbed. That's why we use that verb SpongeBob. 10/3 gets sponged into or absorbed into the constant. Because, I mean, you can take a constant and add a constant, subtract a constant, divide by a constant, as long as the constant's not 0, or multiply by a constant. It's still gonna be a constant. So that's why you get this use of the verb of SpongeBob as a verb. You get 10/3 gets SpongeBobbed into, which is an attention-getting way of saying absorbed into the constant. Further questions? All right. Now, just want to show you briefly what not to do on number 2. It's very common for students to think the answer to number 2 is that, oh yeah, the antiderivative of sine of 3t is negative cosine of 3t plus a constant. Wow, we math teachers see this a lot. It's so not correct. It's not correct. Because we don't have a formula for the antiderivative of sine of 3t. We have a formula for the antiderivative of sine t, which we're going to start calling the antiderivative of sine u. The antiderivative of sine u du is negative cosine u plus a constant. So we have to let u equal 3t. Who would like to predict what we're going to let du equal? In a u substitution problem, you've always got u equals something and du equals something. So, volunteer to tell me what you think du will equal. If you follow the same reasoning that we did up here in problem 1. All right, Wesley.
3 dt.
Yeah, it'd be tempting to just say 3, but it's 3 dt, which is calling for some doctrine, because think about it. We don't have 3 dt. We have dt, so we could make it 3 dt if we doctor this problem up with a 3. Just promise to counterbalance that with a 1/3. So the t version of the integral was integral sine 3t dt. The u version of it is going to have a 1/3 out front. What is the rest of it going to be? Can someone tell me what's going to be in here, in this region? Let's take a volunteer. Transforming this from a t integral to a u integral, what will the u integral be? Anyone want to take a stab at it? All right, Jack.
3 sine u du.
Say it one more time.
3 sine u du.
Okay, 3 sine u du, that tells me exactly what you're thinking. Thanks for saying that. Now, it's actually just sine u du. Because du goes in place of the 3 and the dt together. 3 dt, I mean, multiplication is commutative. I could have put the 3 here or there, right? It doesn't really matter why they put the 3 in a list of factors. 3 dt is defined here as du. Think of this as a translation guide for translating from a t-based language into a u-based language. So if you see 3 dt, you can replace it with du. So, are you okay with that, Jack? You see why this is correct? Okay, so now that we've done the u substitution, so the antiderivative of sine u is negative cosine u. It doesn't matter whether I put the plus c inside or outside parentheses, because it's going to absorb the 1/3 anyway and become a constant. So I think the final answer on this is going to be negative 1/3 cosine of 3t plus a constant of integration. Okay. Let's pause there. Any questions on that one? Sometimes students aren't sure what to let u equal. Like on the first problem, they say, well, do I let u equal x cubed or x cubed plus 1? If you just let u equal x cubed, then, oh, by the way, does anyone actually have this question where you're thinking, well, how do I know what to let u equal? It's not clear to me what to let u equal. Okay. If it's not clear to you what to let u equal, then keep in mind that one way to find out if you're not sure what to let u equal is just pick something. So here's how you just pick something. Suppose you had 10x squared over the square root of 1 plus x cubed, and you didn't know what to let u equal. So you said, well, I don't know, maybe I'll let u equal x cubed. If you let u equal x cubed, du is 3x squared dx. So you're going to doctor with a 3. You'll pull this 10 out front. That's kind of weird. So I could better save. Okay, so you're just going to pull this 10 out front. It's going to be out here instead. You're going to doctor with 3, divide by, and counterbalance with the 1/3. And you're going to end up with something unwieldy. 10/3 antiderivative of du over the square root of 1 plus u. And that's a problem because now we have, it's a lot easier to take the antiderivative of u to the negative 1/2 than it is to take the antiderivative of 1 plus u to the negative 1/2. So it's like, oh, I should have put the 1 in there. And then because the derivative of 1 is 0. Basically, if there's constants hanging around, put those constants in. It's analogous to driving to school on a cold day when you don't have time to scrape off the windshield. Did you notice there was frost on your car windshield this morning, unless you have a garage? How many of you have ever felt like, oh no, there's frost on the windshield, I don't really have time to scrape off the frost? Yeah. Okay, now just imagine, and just go and put your pens and pencils down, because it's important that this is like a big part of doing calculus, math in general. You gotta be willing to drive blind. You don't have to scrape off the windshield. You could just hop in the car and drive blind. I mean, think about it. I mean, you don't want to put your head out the window and look because your hair is still wet from your shower. So you're driving blind, and if you're like, boom, boom, car goes into a ditch. No big deal. You got a phone. Call the tow truck company. They'll pull you out. You just go in a different direction. Going into a ditch, that just means that you need to go in a different direction next time. Keep doing that. Eventually, you might make it to Wheaton Academy. Same thing here. If you don't know what to let u equal, just let it equal something. Drive blind. Mathematicians are people who have the courage to drive blind. They say, I don't know what to do, but I'm going to go in a certain direction. And if it doesn't work, I'll just pick a new direction. I'll let u equal something else. You'll find it eventually. On our next problem, what do you recommend we let u equal? For the first time, we're going to let a student pick. What does your mathematical intuition tell you that we should let u equal on problem 3? Take a volunteer. Problem 3, let u equal what? Shriana, you want to try it? X squared. If u is x squared minus 1, then what would du equal, Mia?
2x dx.
And notice that no doctoring is required because we already have a 2x dx. So go ahead and transform this integral from an x-based integral to a u-based integral, and then try to finish the problem on your own. I'm going to turn off the camera, see how you do, then we'll come back and check it. I love these u substitutions. You take a complicated looking problem and transform it to something that looks really straightforward. I hope you got u to the 4th over 4 plus c. Now why is that not the final answer? Why can't I just leave it as u to the 4th over 4 plus c? What's the principle that says we're not done yet? The principle is if you start with x's, you have to end with x's. So u's are just used temporarily. U's are used temporarily. So I can write this as 1/4 times u, which by the way is x squared minus 1 to the 4th power, plus c. That is an answer that can be considered a final answer. Any questions on this one? Raise your hand if this is what you got before I even wrote it on the board. It's like you had it, you're ahead of me. All right, questions on this one? Okay, I think you can do number 4. Give number 4 a go. I'm going to pause the camera, then after you've worked on it, we'll come back and see how you did. All right, so Paul picked 4x squared plus 3 du equals 8x. With what do, it's not 8x, it's 8x dx. With what do we doctor this problem, class? You have to doctor it up with an 8, because we need 8x dx before we have the green light to replace that triplet of factors with du. Counterbalance with a 1/8. So this is the x-based doctored and counterbalanced. What is the u-based integral? And take Matt for this one. Matt, what would the u-based version be? You start out, this long answer, you start out by saying the antiderivative. And again, I know you were not here for that first lesson. Have you watched the video yet?
I have not. I
Oh.
didn't know if that was happening.
Okay, yeah, because I sent out the email, the message about the video. So yeah, so you're trying to learn 2 lessons at once. Let's go to Elijah. Can you tell me what the u-based version of this is?
1 over 8 integral of 8x.
Well, no.
Or just.
See, because the 8x dx is going to be replaced
Yeah,
with
so
du.
Yeah, so it'd be u cubed du.
Yeah, that's correct. What Elijah said was 1/8 antiderivative, or you can say integral, either one, times the antiderivative of u cubed du. So if you're writing 1/8 times u to the 4th over 4 plus c, then you're almost there. This is going to come out to be 1 over 32 times u, which happens to be 4x squared plus 3 to the 4th power, plus the constant of integration. So we're just going to pause there. Any questions? First of all, how many of you came up with this on your own? You got 1 over 32 times this blob to the 4th plus c. See, widespread success here. Pretty exciting. Any questions on this? That was a great time to ask Paul.
Can you explain how you get the 8 in front?
Yeah, what you got to do is you got to compare your du statement, which is what's being called for. You can't make the substitution unless you have an 8x dx in the problem. We have an x dx, but we do not have an 8x dx. So the existence of this 8 right here is a call for doctoring up this problem with an 8. If you doctor with an 8, you've got to counterbalance with division by 8. So are you okay then with where this 8 came from?
I just don't know where the 8 came from.
Well, wait, do you agree that the derivative of 4x squared plus 3 is 8x? There it is. Further questions? Yeah, you.
So like, I'm just confused, like where did dx go and where did like
Where did what go?
dx go?
Okay, 8x dx got substituted with du. So 8x, in fact, we'll color code this. In red, the 8x and the dx get replaced with the du, because du is equal to 8x dx. And going to yellow, the 4x squared plus 3 gets replaced with u. So we've got u cubed du with a 1/8 up front. So every symbol has to be accounted for. You have to take inventory of every symbol and go from there, okay? Now, do you have any other questions on number 4? All right, let's keep going then. Number 5. 5 has that fragrance of a pre-cooked problem. Because on problem 5, when you let u equal x squared minus 8x plus 1, and by the way, what would du equal? Help me out with that one, please, Shiara.
du would be 2x minus 8 dx.
2x minus 8 dx. Now, some of you are thinking, wait a second, this smells like a pre-cooked problem. Because if you doctor up the numerator by multiplying the numerator by 2, you happen to get exactly 2x minus 8. Come on, what's going on here? What if that had been an x minus 5? Then what would we have done, Mr. Royce? How many of you are kind of wondering that? I mean, yeah, this is a pre-cooked problem. You get pre-cooked problems before, and we're going to teach you how to handle it when it's not pre-cooked. but not today. Okay, so we're just taking it one step at a time. Doctor it with the 2, counterbalance with the 1/2. Try to finish this one on your own. Once again, I'm going to pause the camera, then we'll come back to it when you've had a chance to work. All right, we're back. I have a question for you. The U-based integral will have a 1/2 up front. What will the rest of this be? It'll be 1/2 times the antiderivative of what? Is there a volunteer who'd like to tell me what goes in here? Maybe you think it's been working out for you. Jack, do you want to give that a go?
1 over square root of u.
Yeah, you could have written du over the square root of u, or 1 over the square root of u du. Both of them are correct. What you did is full credit. So now that we got that, then I can write that as 1/2 antiderivative of u to the negative 1/2 du. It's now finally time to take the antiderivative u to the positive 1/2 over 1/2. The 1/2s cancel. You just end up with the square root of u, which happens to be x squared minus 8x plus 1 plus c. Final answer is the square root of 8x squared minus 8x plus 1 plus c. Raise your hand if you got that one. I'm just curious to see where we're at in terms of understanding. Looks like about half of you are saying you did. Thanks, you put your hands up. Now let's go fist to 5. If you're saying that, yeah, I understand this first page, I understand what's going on, you can show a 5. If there's like, whoa, I'm completely lost at 0, and then 2, 3, 4, 5, anywhere in between. Go ahead and show me where you're at. Fist to 5 in terms of understanding. I'm seeing some 4s, some 5, there's a 3, there's a 9. There's a 9. You see that every day when you're doing fist to 5. All right, thanks. You can put your indications down. What questions would you like to ask? Maybe there's something that's confusing. I'd love to help you out here. Question?
So the du is just dropped every time?
The du is not dropped, it's substituted. I mean, although, keep in mind, what's going on right here is the canoe-shaped operator. You were here, oh, were you
I
here?
wasn't in that.
Watch the video, okay? Watch the video from Friday. Okay, let's go to page 2. And, oh yeah, question, Shiara.
For 2, I'm a little bit confused on like signs and negatives.
Okay, so ladies and gentlemen, we can have your attention. For those of you who didn't hear the question was on problem 2. It had to do with how to get from here to here. Okay, so the antiderivative of sine is negative cosine is a claim that can be checked. If you're not sure about that, just open up a new page here. If you're just looking at the antiderivative of sine u du, the cycle of length 4 comes in. If you're taking the derivative of sine u, it's cosine u. Cosine's derivative is negative sine sine's derivative is negative cosine. And when you're taking derivatives, you just start at this cycle of length 4, and when you get to the bottom, you wrap around to the top and keep going. So, do you agree that for derivatives, derivative of sine is cosine? You okay with that? For cosine, negative sine, so this cycle of length 4 looks familiar and you agree with it. So this is for derivatives. When you're taking antiderivatives, you go up through this cycle of length 4, and then when you get to the top, cycle around and go up again from the bottom. So the antiderivative of sine u, we're already at the top, so we cycle around to the bottom to get negative cosine u. Now, if you're uncertain of that, negative cosine u plus c, you can always go back and take the derivative of your family of answers and see if you get back to the integrand. So, the derivative of negative cosine u, well, I know that the derivative of cosine u is negative sine u times u prime plus 0. But if we're taking the derivative with respect to u, we get back to sine u. So, yep, it really is true. The antiderivative of sine u is negative cosine u plus a constant. And that's all we did on problem 2. We took the derivative of sine u as negative cosine u. Okay? Further questions on page 1. All right, is there one more down here that we have to hit? Nope, that's it. Let's go to page 2. Okay. Now, I really believe you're going to be able to get number 6 on your own. I think number 6 is a straightforward practice problem. Please attempt number 6 on your own. I'll do it at the board. You do it at your seats, and we'll see who finishes first. Is there a volunteer who'd like to tell me what you think the final answer is? I've got some of the work here, but my guess is that some of you are done and you're ready to report final answer. All right, Elijah, tell me what you got.
Negative 1/2 cosine x squared plus c.
Negative 1/2 cosine of u, which is really x squared, plus c. It's looking pretty good. It's actually correct. You okay with this one?
Just get rid of the X in front.
Oh, the x in front? Well, you don't get rid of it. Here, we don't get rid of it. Remember that 2x dx,
Well, the
that piece of it, 2x dx, can be replaced with du.
It's just, oh.
The 2x dx, according to our translation guide, gets replaced with du.
Is that
And the x squared gets replaced with u. So we've accounted for everything to the right of the antiderivative. Simple. All right. Now, number 7 is going to feel a lot like the homework that was last night. Unless there's any other. Do you have any other questions? I notice there is some side talking. Cindy, do you have a question on this one? You okay? All right. Well, let's table that conversation then. Let's go on. Turns out, oh yeah, you go ahead.
So where does that x go?
Well, 2x dx isn't, oh, yeah, that was my fault. Now I see why you're confused. Because when I took the derivative of x squared, I should have written 2x dx.
Oh, okay.
So, yeah, that was totally understandable. That's what the side conversations were about, huh? The missing x? All right. So, number 7 is, there's an important lesson here, and that is the fact that you know how to do u substitutions does not mean that you use u substitutions every time. This is a problem where cosine squared x is rewritten as cosine x times cosine x, which is sine over cosine is tangent x secant x. You don't need a u substitution for that because you know the family of functions whose derivative is secant x tangent x. What is that family? Raise your hand if you think you know. Yes, Crystal.
Secant x.
Yeah, so secant x plus c is the answer. We don't always have to use u substitutions. In fact, if you tried to do it here, it would mess things up. Now, problem 8 is the kind of problem that is significantly more challenging. And so it's going to be the beginning of day 2 of our 2-day lesson. Day 2 starts right here. And so that means that the homework is not due tomorrow. Homework 4.3 is due on Thursday. Now, if you want to do some practice problems, you can just go through and start doing odd-numbered problems. But no homework due tomorrow. You are dismissed.